Hello, welcome to NPTEL online certification course on Introduction to the Application of AI to Robotics. Today we are going to talk about AI. What AI is, what are the features of AI, and what features of AI are helping robotics to become more and more autonomous, right? Last class we have seen the introduction of robotics, where we have seen all the features of robots, okay. So, here in this lecture I am going to give you a overview of AI, and we will be studying much more detail about this when we will be coming to the specific topics. Okay. So, I expect that at the end of this lecture you will be able to have an broad overview of AI and its usefulness in robotics. Okay. So, I will begin with what is AI, then we are going to talk about important concept of AI, that is the machine learning, then we will move on to deep learning, AI perception, planning and decision making, and finally AI in robotics. So, what is AI? Okay. It is a science and engineering of making intelligent machine, and this is the definition given by John McCarthy in 1956, who coined this term AI. Okay. So, the features which we expect from AI is thinking humanly, okay, that is the cognitive modeling approach, simulate human thought process, then acting humanly, it should go through the Turing test approach, what it is that we are going to see a little later, and then it should think rationally, okay. So, that should be there, and not only thinking, it should act rationally as well, okay. So, these are the features we want AI to have, okay. Now, if I am talking about, say, what is the difference between an AI robot and the regular robot which we are seeing, okay, all around. So, actually in AI robot, we want the AI robot to take its software to take its own decision, okay, and not only taking its own decision, it should be able to adapt to environment based on the data which it is getting from its sensors. Okay. So, essentially in the regular robot we have the hard coding, basically for a specific type of action we do the programming. Okay. So, we are with AI robot, we are trying to move from that hard coding to autonomous decision making, basically. Okay. So, instead of programming all the robot's behavior in advance, we expect that the robot software will learn from the example. Okay. Let us go for a brief history of AI. Okay. So, it is always better to know before studying a topic what its history has been, how things have progressed over a time. So, the Turing test that was proposed in 1950, then 56 John McCarthy coined the word AI, as we have seen in the last slide, and so AI was founded. Then 1980s there were a lot of talk about expert system, and those were nothing but the rule based AI, basically. Okay. Then 97 came the Deep Blue, that is the IBM chess computer beat over the world champion Kasparov. So, that was there. Then 2006 deep learning came, and Hinton at University of Toronto, basically he revived the neural network, alright, and from here the modern AI has come up. Okay. So, then 2012 we have the AlexNet was there, then 22 the ChatGPT, LLMs as we have all seen, and then 24 the foundational model, that is the multimodal AI, where we have the combination of vision plus your language plus action, all these have come up. So, what type of intelligence, what type of artificial intelligence there? Okay. So, if we look at it, so it can be classified into three types: the narrow AI, where we are currently, then you have the general AI and the super AI. In narrow AI, excel at one specific task, okay, say robotics control. In the general AI, we expect human level reasoning across all the cognitive tasks, and in the super AI, we expect it will surpass human intelligence in every domain. Okay. Coming to the Turing test, which is a very prominent test, judge whether a system is artificial intelligent or not. So, the test state says that a human judge converses, say via text, with a human and a machine, alright, and if judge cannot reliably tell which is which, that is then the machine passes the Turing test. Okay. And this was proposed by Alan Turing in 1950 in the paper Computing Machinery and Intelligence. There are many components needed for this thing to achieve, as we will be seeing them further in detail, say NLP, how we represent the knowledge, automated reasoning and machine learning. Okay. No machine has fully passed and restricted Turing test. Okay. So, what are the core branches of AI? Okay. So, if we look at the core branches of AI, so these are machine learning, okay, where the machine learns patterns from the data without explicit programming. Then we have the computer vision, where it interprets and understands the image and videos. Then we have the natural language processing, understand and generate human language, robotics and embodied AI. Then we have a planning and reasoning, evolutionary algorithm, multi-agent system and the representation of knowledge. Okay. So, these are the core branches of AI. We are going to see some of them over here today, and I will be introducing those to you. Let us come to the first one, the machine learning. It is the most popular form of AI, and here basically we are learning from the data. Okay. So, we have you have lot of data, and from that data we learn, okay, the machine learn. So, we design and develop software that can learn from data, and based on this learning model we perform the prediction or prediction on unknown data. Okay. So, the main constraint here is that these programs are limited to the power of the data. Okay. And if naturally if your data set is small, then learning model is also going to be limited. Okay. So, coming to the definition given by Tom Michel about learning, it says that a computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance at task T as measured by P improves with experience E. Okay. So, as I was telling you, in traditional programming, okay, see I am going to talk in this lecture most of the time from the robotics perspective. Okay. So, in traditional programming what we do actually? So, we have rule, okay, that is the program you write, you give some input to the program, that is the data, and you get the output, alright. But in machine learning what we have data and we have the output. To say that we have input and we have output and we generate the rules. So, that is the difference between the traditional programming and the machine learning. So, here it is a human written logic basically, and it is difficult when the rules are complex. Okay. And in the machine learning, algorithm discovers the pattern and it can scale to the complex problem. Say example could be simple if else type of if then if else type of statement here in the traditional programming, and in machine learning you could have say we could have some model. So, for a certain type of sensor data it could take certain type of action. The machine learning can be classified into say supervised, unsupervised and reinforcement learning. So, in case of supervised learning, actually what we do is that we learn a mapping from X to Y, alright. So, you are given says for a certain type of input you have the output. Okay. So, from the label training example we have the pair label training example, this mapping learns a mapping, alright. So, suppose I have X, I have Y and we have say these data, alright. Now, this supervised learning is of two types. One is the regression. All of you must have studied in your statistic course. The regression, it predicts continuous values basically. In the example, in the robotic sense, it could be robot joint angle prediction, control signal estimation, or the depth from the image. Alright, you could have a output, say the mobile robot velocity says 2.37 meter per second. Alright, so here basically in the regression what we do, we have the data, these are the data for given x, what is the value of y. We try to fit a line, say in case of simple linear regression, okay, and from here we actually try to generate the equation, say y is equal to mx plus c, right, where c is this y intercept over here and m is the slope. So, from this data we through regression we get this expression, then I can predict for any x what value of y is going to be, right. So, there are key algorithm for the regression. These are the linear decision trees, random forest, support vector machine, k nearest neighbor, and neural network and deep learning. The another type of supervised learning is the classification, okay, and in classification basically it predicts the discrete class, okay. For example, here say for a certain x and certain y we have the data given like this, say some red mark and some this triangle mark. So, I can classify say that this is say one class and this belongs to the other class. This is for the binary classification, say 1 and 0, alright. But we could have the multi-class classification also, alright. So, in the multi-class classification we may have the more than more than two classifications. So, it is an example in robotics includes say object recognition, identification of the gesture and obstacle versus the free space. Okay. So, for example, in a video if you want to identify an image, you can say that okay, this is the pedestrian. So, that could be the form of output. Key algorithm here are logistic regression, decision trees, random forest, support vector machines, k nearest neighbor and XGBoost. Next is the unsupervised learning, and in unsupervised learning actually we find hidden structure in unlabeled data. The previous one we had a labeled data, that is for this input you are going to have this output in case of supervised learning. But in case of unsupervised learning we do not have the data labeling. Okay. So, for example, if we mark x and y, your original data is something like this, then in clustering, which is a type of unsupervised learning, okay, we could group the say similar data at a place, a single cluster. Okay. So, in clustering we group similar data point, k-mean partition into k clusters, then you have the DB scan, density based cluster, hierarchical clustering is there, principal component analysis, and in robotics we may have the terrain type segmentation, pedestrian group detection, like that. So, one group of pedestrian going, another group of pedestrian going. So, that type of clustering we can do. In unsupervised learning, generate the model, okay. So, learn to generate the new samples, okay. So, now for example, synthetic training data, world model simulation, we would like to have the dimensionality reduction. For example, your sensor data is there, so we would lot of sensor data is there, so we would like to compress that, okay. So, we compress data to the fewer dimension. Many times we would like to have the anomaly detection, okay. For example, in this data, okay, if something say far off is here, okay, so this may be considered as anomaly which does not belong to this data. So, that type of anomaly detection can be done. In robotics, these examples are fault detection, unexpected obstacle classification. Next type of learning here is the reinforcement learning. Okay. Now, in case of reinforcement learning, actually what is done is that an agent learns to make decision by interacting with the environment, okay, and in turn the agent receives reward or penalties for its action, okay, and here the goal is to maximize the cumulative reward over time. Alright. So, you have agent, you have the environment here, it performs certain action, agent performs certain action on the environment, okay, and environment gives an award to the agent, in turn it gets an award to the agent, okay, based on its action. So, here states basically agent's observation of the environment at time, that is what we call as state. It could be the sensor reading, joint angle, camera image and so on. Action could be choice made by the agent in, okay. So, in robotics it could be motor command, alright, joint velocities, or whether we want the gripper to open or close. So, that type of thing could be there, and these reward are a scalar feedback signal basically, okay. Policy maximize cumulative reward, okay. So, the policy is strategy mapping states to action, okay, and the goal of here reinforcement learning is to find the optimal policy. Then we have the value function here, expected say Vs is the expected cumulative reward from the state, and say Q is basically the value of taking action A in the state S. And then we could also have exploration, okay. So, that is there, and the reinforcement, popular reinforcement learning algorithms, the Q learning, the deep Q network and the policy gradient method. We will be seeing much more in detail this topic in our subsequent classes. So, coming to the application of machine learning in robotics. So, it is used for the object detection and recognition, grasping and manipulation, locomotion control, imitation learning, anomaly and fault detection, human robot interaction, okay. I will be discussing further about this, then semantic mapping as well as the path prediction, okay. So, you can see that there is a whole gambit of area in which the machine learning is applicable in robotics, okay. So, next let us look at the deep learning. So, the machine learning types which we have seen, that is the supervised, unsupervised and reinforcement learning, these are what we call as the statistical machine learning. Here your data is usually structured data, that is it is there in the tabular form, but if your data is unstructured, okay, so in that case these statistical learning method does not work. For example, if you have the visual data, okay, images from the camera, or if you have an audio file, okay, then statistical machine learning does not work, okay. So, to take care of these issues, the deep learning model can be used, and it can extract information from the raw unstructured data, okay. And some of the types of the deep learning models are the neural network, CNN, and that is convolutional neural network, recurrent neural network and the transformers. Again, I will be talking detail about these in the subsequent lectures. Here we will be just seeing the brief, okay. So, coming to the artificial neural network, it is a core of deep learning, okay, and it is inspired by the human brain. There are billion of parameters depending on how many hidden layers you have, alright. And this is, it powers the modern AI. We could have the forward neural network as well as the backward neural network. The aim of the forward neural network is basically to make the prediction, whereas in the backward neural network we adjust the weight, okay, so that our model gets refined. And here in case of neural network we have the input layers actually. Then we have the layers of hidden layer, you could have one layer, two layer or more than two layers, okay, and then you have a output layer, okay. So, here we define the neurons here, okay, and these neurons basically what they does it, they compute, okay, what? So, they compute here say A, that is the output coming from a neuron, alright. And this could be basically the summation of the weight and the inputs. So, suppose you have the weights inputs over here and you have the weights over here, right. So, this plus if there are some biases, Okay. So, if there are some biases, so those biases can be added and then they can be passed on to the activation function. Okay. And that is how we get the output. Activation function, the very popular one are the ReLU and the sigmoid activation function, and we use the loss function to measure the prediction error. The neural network architecture, it is a feed forward neural network, the one which I just discussed. There are no loops into it, it is not good for the sequential data. The recurrent neural network, they have got loops in it, it is useful in context. Memory, they affect the future output. Okay. For language translation, speech recognition, they are used, and bad for long term memory. So, LSTM is used there. Next is the CNN, the type of deep learning, exploits the spatial structure in image through local connectivity and parameter sharing. Okay. It looks at a small patch of image at a time, and thus it reduces the input size, and it is used in the object classification and video analysis. Next is the transformers. Transformers replaced RNN for sequence modeling. It is a foundation for all the modern LLMs and many robot learning systems, and in the transformer basically we calculate the attention score. Again, I will be discussing much more details about this in our coming lectures. Next, let us see what is AI perception for robots. Okay. So, in the AI perception, what we do, first we try to sense, okay, and for sensing we use the sensors, say LiDAR, camera, IMU, or the 4 sensors. So, through these I can sense, then I process those sensor data, okay. So, we can filter it, extract the noise, then perceive, object detect, scene map, we can detect the object, we can create the scene map, then decide, that is we can plan path, choose action, and then we can act. So, we can have the motor command and feedback. And for AI perception we use computer vision, point cloud and sensor fusion. Okay. So, in computer vision basically what we do, we acquire the image, alright, we pre-process the image, then we extract the features, we detect the object, and then we have the understanding about the scene. Okay. And through this we can have image segmentation, we can have the estimation of the depth. Okay. We could have the 6 degree of freedom object pose estimation, as well as we can have the visual SLAM, that is the simultaneous localization and mapping. Then we could also have the 3D perception through LiDAR and the point cloud. So, LiDAR sensor produce point cloud, which is nothing but its XYZ coordinate, okay. That is unordered set of XYZ coordinate of the 3D point, okay. So, unlike images, point cloud lack grid structure. In images we can always make a grid structure, okay, but with the point cloud we cannot make a grid structure, okay. So, it requires special neural network architecture to deal with that LiDAR sensor data. Okay. So, the point net came in 2017, it processes each point independently and then aggregate with symmetric functions and handles permutation invariance. Next, let us look at the multimodal perception. Multimodal perception we can have when we do the sensor fusion. Okay. Sensor fusion means we have the data from the multiple sensors, say camera, LiDAR, radar, IMU, GPS and sonar. We want to fuse these sensor data. Okay. So, the fusion strategies could be early fusion, we could have the mid fusion and we could have the late fusion. Okay. So, this way we can do this sensor fusion. Then next important concept of AI which is used in robotics is the natural language processing for the robots. Okay. Robots must understand and generate natural language to collaborate with human. Basically, this is very much important where we are talking about the human robot interaction. Okay. So, the communication with the robot and based on the commands or tasks given by the human, the robot can behave. Okay. So, it is a various component comprises of recognition of the speech, okay, and language understanding, task grounding as well as the dialogue management. Next important aspect of AI which is used in robotics, that is the search. Okay, it is used extensively in AI programs, and these programs examine a large number of possibilities and then pick the most useful path, okay, optimal path. Okay, the example could be say networking, resource allocation, scheduling, and so on. Search algorithm for robot planning, okay, they find optimal action sequence in structured state space, okay, and this search could be uninformed, say blind search, or informed, the heuristic search. So, uninformed or blind search, we could have the say width first search, we could have the depth first search, uniform cost search, or iterative deepening search. Okay. Then in the heuristic search, we could have the greedy, A star, RRT, and D star light. Again, I am going to talk about these methods in our subsequent lectures. Next is the Markov decision process. So, sequential decision making in stochastic environment, okay, where an agent chooses action to maximize the cumulative reward. So, this is what Markov decision process is. Okay. So, the Markov property means the future depends only on the current state, not on history. Okay. And these are the important aspect in Markov decision process, that is the state space, action space, transition model, reward function, discount factor, and the policy. So, next is the robot motion planning. Now, in robot motion planning, we could have the global planning, local planning, or the task planning. Okay, so we could have the planning at any level, either local level, global level, or we could have planning for the task. Next is how do we represent a knowledge, okay, how AI represents and reason about knowledge. Okay. So, there are many ways of doing it. One is say propositional logic, and then we can do it through ontologies, okay, first order logic, probabilistic graphical models, semantic networks, and through the LLM. So, this way we could have the representation of the knowledge. AI in robotics basically bring intelligence to the physical system. So, we have perception, we have planning, and then we have the action. Okay. So, the SLAM, that is simultaneous localization and mapping. So, suppose this is a room, and in this room you have some static obstacle over here, and say this is your robot. Now, this robot actually should know where it is. Okay. So, it is a basically problem, that is what we call as the chicken and egg problem. Okay. To build a map, you need to know your location, but to know your location, you need a map. Okay. So, the SLAM solves both the problems simultaneously. So, we have the localization, where it says that it localizes where it is, then it has the mapping, that is how does the environment look like, then simultaneous, both computed together in the real time, that is localization and mapping, and these are some of the key algorithm. The robot learning paradigm consists of imitation learning, inverse RL, then learning from the human feedback, simulation to the real transfer. Okay. We could have say a robot simulated, and then we can transfer that simulation data to the real robot. That is how most of the robots training is done these days. Then you have the meta learning and the world models. AI in robotics. So, basically what we are doing here, okay, using AI in robotics. So, we have the sensor gives information about environment, then we plan, and then finally we execute it, okay, and we have the continuous feedback here. So, there could be various ways of which help us in decision making, say the classical task planning, behavior trees, finite state machines, LLM based planning, then model predictive control, and the reinforcement learning policy. Okay. Next few of the slides I am going to talk about the application of these AI in various type of robots basically. So, if we talk about the autonomous robot manipulation, then we can use AI for the perception purpose, for the planning of the grasp, for the motion planning, and for the control. I have given some details of these which you can go through and study. Okay, if we talk about AI in autonomous vehicle or say self-driving car, then what all we are doing it there. Okay, so essentially we are sensing through sensor, we are having perception. Okay, then we do the prediction, we have the planning, then we have the control, and in all these we take care of the safety. Then in human robot interaction, if say person has to interact with a robot, okay, then we need speech and natural language processing. We must be able to have the gesture recognition, emotion and expression, safe physical interaction, prediction of the intent and the explainability. Okay, and these AI robots are very much used in the medical and service application, say your whether it is a surgical robot, in exoskeleton for the rehabilitation purpose, service robotics, domestic robots, agricultural as well as the inspection robots. Now we need to have AI which is ethical as well as which is responsible. Okay. So we need to see that we do not have the algorithm biases, okay, and we must see that safety and reliability is ensured. It should things should be explainable, privacy of the pupil from whom you are collecting the data, okay, or that aspect has to be taken care, and the human autonomy has to be seen that you have provision for the human intervention. Okay. So, the AI robot technology stack, if we look at what all we have, okay. So, we have basically AI algorithm, then we have the middleware say like ROS, then we have the sensing and actuation, and we have the hardware, and then all these things are applicable for the various type of applications, surgery, construction, agriculture, defense and so on. There are key benchmark and data sets in AI robotics. I have just summarized these for those who want to do some study in these. Okay. So, these are the data sets which can be used for various type of activities in the robotics. Where the AI and robotics are heading basically. Okay. So, if you look at the foundation model for the robots, we have GPT-4 or multimodal LLMs. We have the concept of embodied AI, okay, that is the AI agent that interact with the physical world. We have the human robot collaboration, we have the neuromorphic and AGI, safe and trustworthy AI and data efficient robot learning. Okay. So, AI concept which are applicable in robotics, here is the quick reference guide here. So, your supervised learning say for object detection, pose estimation, reinforcement learning for locomotion, manipulation, navigation, computer vision for perception, obstacle avoidance, LiDAR processing for 3D mapping, object detection and so on. Okay. So, this way this will help you to have a quick reference. So, to summarize, AI is a diverse field, okay, that we have seen. Data is the foundation, perception is the first thing which we do with the help of sensors. There are uncertainty challenges real, okay, so we can use the probabilistic method to take care of that. Then there is end-to-end learning and foundational era. You have the vision language model, VLM, LLMs, revolutionizing robot generalization, and of course, in doing all these things, the prime concern of the user, that is safety, that has to be taken care. Okay. So, with this I would like to close. Thank you.